So on page 456, question 11.105, we're creating a solution of HCl by mixing HCl gas with water. And then it says we're titrating that with NaOH. A titration is like a neutralization reaction where you add an acid and a base together. So instead of saying it was titrated with NaOH, I would probably say that NaOH was added to that solution until it was 100% neutralized, which is what happens in a titration. So the reaction that's first happening is the HCl is dissolving in water, and that actually does cause a reaction. What should the products of that reaction be? What do we know about HCl? It's a strong acid, right? It's on the formula sheet as a strong acid, which means it should be able to donate or give up its H plus to a water in pretty much a 100% reaction. So as a strong acid, once it donates that H plus, the H plus is not going to come back onto it. So the HCl donates an H plus and ends up with the Cl minus. And the water will be forced to accept a third hydrogen in addition to its original two to make H3O plus. So it's telling us something about the amounts. So we're starting with HCl gas. And what we know about this sample of gas is that it's in a container with a volume of 189 milliliters, and since a gas will expand to occupy the entire container, that's also the volume of the gas. 25 degrees Celsius. So for any of the calculations we did dealing with gases, they all require us to convert Celsius temperatures into Kelvin. So if we add 273, we'll get 298 Kelvin. And it tells us that the pressure is 108 millimeters of mercury, so also we didn't deal with any examples using that pressure unit. So on the exam, if I'm giving you a pressure unit, I would just give it to you in atmospheres. But in this case, since it is 108 millimeters of mercury, the conversion is 760 millimeters of mercury equals 1 atmosphere. So if we apply that conversion, we get 0.142 atmospheres. So what we know about the gas is the pressure, the temperature, and the volume. So that's the information about the gas, and then as I said, it tells us it's titrated with NaOH. That means this NaOH is added to this solution. So we've created this solution by adding the gas to water, and we're assuming since it's a strong acid, every molecule or every mole of the gas that's added reacts with water to produce, since when this is balanced, everything's 1-to-1, 1 mole of H3O plus. And then the reaction that occurs between the H3O plus and the NaOH is another it's a neutralization reaction. So what should the products of that reaction be? When an acid and a base react together, the acid gives an H plus away, and the base accepts it. So the base is the OH minus. So we talked about that as an example of a base. Anytime you have a metal that already has a positive charge, it's not going to be doing anything. It already has a noble gas configuration. It's just there as an Na plus. The base would be the OH minus that's associated with that metal as a negative charge on it, so it can pick up an H plus and get balanced, right? So if an OH minus picks up another H plus, I make a water. And when the H3O plus gives up an H plus, I also make a water, so I get two waters there. And those are both strong, so this will again be a 100% reaction, and it's reacting in a 1-to-1 ratio. So in a titration, you get a 100% of all acid and base neutralized. So probably I wouldn't use the term titration since we didn't really talk about that. But you should know what that is. A titration is where an acid and a base are added together and neutralized 100%. So what that means is the mole ratio I get in the balanced reaction allows me to relate the quantities of these things reacting if they're reacting 100%. If it's a 1-to-1 mole ratio, that means the amount of NaOH I've added in moles is equal to the amount of acid that was there in moles, because they're present in a 1-to-1 mole ratio. So that allows me to say 1 mole of acid equals 1 mole of NaOH. So far I haven't really done any problem solving. I'm just establishing all of the information that's given in a clear way so I understand exactly what the situation is. So then to attack this problem, I want to analyze what they're actually asking me. What they're asking me is, what is the molarity of NaOH? What is molarity? It's a concentration unit, and molarity and concentration means, right, moles per liter. So the molarity of the NaOH is how many moles of NaOH equals, or per liter of solution. The NaOH solution. That's what they're asking. So what we want to know is how many moles of NaOH are in that 15.7 milliliters of NaOH. And then we want to set it up with units of moles per liter instead of moles per 15 milliliter. So this is the key thing we have to recognize to solve this problem. The point of the titration is if I'm adding a certain amount of NaOH and I know the volume of space that that's occupying, but I don't know how many moles are in there, I don't know what the molarity is. If I want to know the molarity, I have to know how many moles of NaOH are in there. And from the given information, the only way to get that is to recognize that the moles of NaOH that are being added, that 15.7 milliliters, must be the amount necessary to provide a number of moles of NaOH that's equal to the number of moles of acid if I'm going to do the titration and it's going to be 100% neutralized. So if I could figure out how many moles of acid I have, then I'll know how many moles of NaOH were added to neutralize it, since they're reacting in a 1-to-1 ratio. So, since the acid is starting as a gas, I'll probably want to use the ideal gas law since that involves a number of moles of gas. And I know the number of moles of HCl that I started with gives me the equal number of moles of H3O plus, which requires an equal number of moles of NaOH. So I need to know how many moles of HCl there are, and actually, because of the way the reaction's balanced, I can even go here. I can say the moles of HCl I'm starting with must be equal to the moles of NaOH that were added. The point of the titration is to completely neutralize it. So I'll solve this for moles, and then I plug in. Do I have the information I need to plug in? Sure, I've got pressure, volume, temperature given, and I know the value for R. So the moles of HCl, which is also the moles of NaOH, should be equal to the pressure of the HCl gas times the volume that was in, 189 milliliters. The value for R, 0.08206 liters atmospheres per mole Kelvin. And I need the temperature on the bottom, which was 298 Kelvin. So I'm canceling kelvins, canceling atmospheres, but the liters and milliliters don't cancel. So I need another conversion step. I need to get 10 to the third milliliters equals 1 liter, so that will cancel, because all I want here is moles. So the number of moles of HCl is 0.142 times 189 divided by 298 divided by 0.08206 divided by 1000 gives me 0.001098. I'm going to keep 4 sig figs for now because I only want to round at the end. But I do know that I'll at least be limited by the 3 sig figs here and here in the end. So that, as we said, is the moles of HCl. It's also equal to the moles of NaOH. And so if I want the molarity of the NaOH, I want the moles of NaOH. Per liter of NaOH, but what I have given about the NaOH is 15.7 milliliters. So there I need a little more space to do my milliliter to liter conversion. So I've got moles of NaOH per liter of NaOH solution. And I get a molarity of 0.0700 molar. And that's 3 sig figs. Questions about that one? So what's the point of a titration? What? Right. So in a titration, we want to, if we have a certain amount of an acid or a base, we will add some of the other substance to neutralize them. So if I have an acid, I add a base. If I already had a base, I would add an acid to neutralize it. So the point is to neutralize it, but it also allows us to quantify how much we might have, because when you do a titration, you can determine the point in the titration when this is occurring, the point at which you've added a number of moles of acid that's equal to the number of moles of base. That allows you to do the type of problem that we just did. It allows you to determine if I have some solution of NaOH and I don't know what its concentration is, I can use the titration data to quantify how many moles of NaOH are in there. Usually a titration is done if you have an unknown amount of moles of something to start with. So maybe I have some acid that's an unknown or something. I don't know how many moles of it are there. If I add base until the acid is 100% neutralized, if I can determine how many moles of base were added, if I know its molarity and its volume, molarity times volume equals moles, so I can add that in there. And if I know it took 10 moles of the base to get the acid neutralized, I know I had 10 moles of acid to start with. Other questions? That came from plugging in. I had to erase it to create space, but it came from plugging in to the ideal gas law and solving for the number of moles. So I plugged in the temperature, volume, and pressure for the HCl to get the moles of HCl, since that was the gas. So that was the conditions that the HCl gas was under before it was added. So I used that to figure out how many moles of HCl were added to this solution, and then I knew that was equal to the moles of NaOH required to titrate it.